Welcome everyone to the next lesson in this series, and in this video we will look at IPv4 and IPv6 dual stack networking for Kubernetes. Now throughout this series we've explored a lot of networking concepts, and all of that have been using the IPv4 protocol. Now, the IPv4 address space is limited and scarce, and then as we run out of addresses, organizations are evaluating and looking towards migrating to IPv6. Now, I've already worked with organizations who've made that transition, and when your clusters are interacting with both IPv4 and IPv6 workloads and services in and out of the cluster, you need to run something known as dual stack networking so that your workloads can be compatible with both these protocols. So in this lab, we will look at how you can run a dual stack Kubernetes cluster with Calico. Let's get started. Okay, so this lab is lab number 14, and the directory for this lab is 14-calico-IPv6. I have already gone ahead and deployed the lab in my environment. And if you look at the lab topology, we have a control plane node and two worker nodes. And these nodes, unlike the previous labs, have both an IPv4 and an IPv6 address. And the top of rack switch also has in VLAN 10 an IPv4 as well as an IPv6 address. Now, in addition to the interfaces that connect to the nodes in the cluster, the top of rack switch also has a loopback interface with an IPv4 and an IPv6 address. And we'll look at how pods in the cluster can connect to both these addresses, both these loopback addresses, using IPv4 and IPv6 protocols respectively. All right. And we will also look at how we establish intra-cluster IPv6 and IPv4 communication in this lab topology. Now, when you are configuring a dual stack Kubernetes cluster, you need to follow the lab setup guide for your respective platforms. Now, in this kind cluster, we have provided a pod and a service subnet from both the IPv4 and the IPv6 ranges. If you look at the pod subnet, it has an IPv4 range as well as an IPv6 range, and the same goes for the service subnet as well. Okay. And this configuration has to be provided typically during startup and cannot be modified after your clusters have been spun up. So just bear that in mind, although that could differ based on your platform. Now, if you look at the node IP configuration for the kind clusters, for each of the nodes, we've also provided an IPv4 as well as an IPv6 address. So at each layer of the networking stack, from the nodes to the pods to the services, we have IPv4 as well as IPv6 addresses. Now, Calico is what assigns IP addresses to pods. So if you look at the Calico installation manifest, this too has an IPv4 IP pool as well as an IPv6 IP pool. And in the lab, we will look at how the pod receives two IP addresses from both these address spaces. All right, so once you've spun up the lab, go ahead and export the kubeconfig file for this lab, and you can inspect the lab topology. It's a relatively straightforward topology, very similar to what we've used in the previous labs as well. Okay, and if you do a kubectl get nodes, we have a 3-node cluster for this lab setup. And if you look at the internal IP addresses for the nodes, it's showing the IPv4 IPs. And if you look at the ETH1 interface configuration, for example, in this case, in the control plane node, this interface has an IPv4 as well as an IPv6 address. Okay. Now, I can also do a Calico Cuttle get IP pools. And if you recall, our installation resource had two separate IP pools defined. So what that means is during install time, the Calico operator will consume the installation resource and in turn configure two different IP pools. So we have an IPv4 as well as an IPv6 address pool. Okay. Next, I'm going to do a Calico Cuttle get workload endpoints. And what this is going to show is the pods configured or deployed in this cluster, as well as their IP addresses from a Calico data store standpoint. So if you look at each of these pods, these are the multi-tool pods. They have an IPv4 as well as an IPv6 address, along with their Kali interface that Calico configures for pod networking. So just bear in mind that due to the fact that we have two different IP pools, Calico has gone ahead and assigned these pods two different IP addresses from the two different IP address spaces. Okay, so with everything configured, what we are going to do now is run some connectivity testing. So first, from one of the pods in the cluster, from one of the multi-tool pods, we are going to ping the 1.1.1.1 address, which is basically the address, the IPv4 address configured on the loopback interface in the top of rack switch. Okay. And as you can see, the multi-tool pod is able to ping that IPv4 loopback interface. We're going to run the same ping, however, this time to the IPv6 loopback interface. Now, the reason this multi-tool pod is able to ping both of these addresses is because it has an IPv4 as well as an IPv6 address, which means it can connect to workloads running using either of those protocols. Okay. So if you want to understand how the detailed underlying routing works, if you look at a pod, the pod has a default gateway configured. So when it has two IP addresses, it's going to have a default gateway configured for IPv4 as well as a default gateway configured for IPv6. Now, this gateway is basically a Calico virtual IP that ensures the packet gets sent out to the opposite end of the virtual Ethernet pair. Now, when the packet lands on the opposite end, it's going to be in the node's host namespace. So that routing table is going to do a lookup and then forward the packet to the next hop. Now, in this example, we were connecting to the loopback interface of the top of rack switch. And in the node's routing table, the default gateway for both IPv4 and IPv6 points to VLAN 10. And this setup is very similar to the previous labs as well. So the node forwards the traffic to VLAN 10, and the upstream switches a routing table. Given that this loopback interface is configured in the switch, will have a route to that IP address, and then it gets forwarded to that loopback interface. And this is how the end-to-end routing works for both IPv4 as well as IPv6. The important thing to note here is that the pod has two interfaces, IPv4 and IPv6. It's going to have routes for IPv4 as well as IPv6, and the same setup is also present in the node as well. And that's what makes forwarding in both protocols possible in this case. All right, so I'm going to break this lab into two separate videos. In this video, we looked at the underlying interface configuration for IPv6 as well as IPv4, as well as how a pod in the cluster can connect to services using both of those protocols. In the next video, we will look at how intra-cluster communication takes place for both of these protocols. So I'll see you in the next one. Bye for now.